Okay, today we're going to go over yesterday's homework, and then we have a little lesson today, and today we are talking about where a function is positive or negative. Tomorrow we do rates of change, and then quiz Thursday. Quiz Thursday. Did y'all see that on all the calendars we just looked at?
Is this Thursday?
Quiz is Thursday. Okay? So if we go back and take a look at these calendars, we see that we have a quiz Thursday. And then the next Friday, we have another quiz. Look! Point opportunity. Point opportunity. All right. So let's take a look at this homework. So yesterday we added back in some of our characteristics we studied way back in the day when you took Algebra 1. So yesterday we added domain range. We talked about maximums and minimums, and we classified those as local. What was the other word for local? Relative. Good. Still written on the board. Okay, so if you see relative or local, those mean the same thing. Now, this one has an absolute max right here. This is an absolute max because it is the highest point on the graph. There are no y values greater than the y value that occurs at this point. That's why it's an absolute max. Now this is higher than the points around it. So it is also a max, but it is not the highest point on the graph. So this one is that local max. Now, here we have a valley. So our peaks and our valleys are our extrema. Extrema is the word that we use for minimums and maximums. So this is a valley, which makes it a min. Now, it is also a local min because even though it is lower than the points around it, this y value is less than the points on either side of it. It is not the lowest point on the graph because it keeps going down forever. Okay, so with polynomial functions, what did we say the domain of every polynomial function is? Negative infinity to positive infinity. Okay, and now we have to use our graphing calculator to find the other details in this problem. Okay, so when you use your graphing calculator, I told you 3 decimal places and my key has 2 on it. Did you get that this was the point, negative 1.59 and 4.25? Okay, did you find that this local max occurs at the point 0.41, 0.73? And this local min occurs at the point negative 0.46, negative 2.70.
When you did this with us,
Huh?
when you did this with us in class, you put the y values. You said y equals this.
Okay, so these are our points. So when I look at the max and min, this absolute max, I would say y equals 4.25 at an x value of negative 1.59. Now, if you just write that's a max, that's not a min. Sorry, I just slid that in the wrong spot. If you just write the point, I will not count it off. But this notation gets you ready for pre-calculus. So those of you that are going to pre-calculus, when we look at a max, it's the maximum value of the function, which is really the y value. So you state the y value and tell you the x value where it occurs. But if you guys just write the ordered pair, I'll give you full credit. Yes, ma'am?
Does it matter if I had negative 1.6 instead of, or does it have to be precisely negative 1?
Okay, on our test, whatever number of decimal places I ask, it should be rounded to that nearest percent, that nearest decimal. So if I say to the nearest 100, then that 100 should match my answer here.
Well, because this one is a count, you took it on its own.
It didn't say. It wasn't specific. Yes, ma'am?
My calculation not set up right.
Okay.
It doesn't.
The decimals are off? Okay, all right. We'll do one together in just a minute, and I will check that with you. All right, so this is a local min, or relative min, and the y value is negative 2.7, and that happens at an x value of negative 0.46. Then we have a local max, and this local max occurs at this point. So my y value is 0.73, and that occurs at an x value of 0.41. Okay, those of you that used your calculator, and if you didn't get something really, really, really close, like would round to these numbers, then we do need to talk during today's lesson at some point. I need to see what's going on. If it's a calculator issue, we'll fix it. If it's an issue with punching it in correctly, we'll work on that too. All right, now range. Range is your y values. So when we look at the range, we go from the bottom to the top. Bottom to the top, least to greatest. Well, this goes down forever. How do we describe down forever? Negative infinity. To the top, what is the y value there? 4.25. Now, this 4.25 is part of the graph. We include it. To denote that we include that point, we use the bracket instead of the parentheses. Now, the reason we don't use the parentheses with infinity is not a number. It's an idea. We can never get there. Every time I say infinity, do any of you think of Toy Story?
Infinity and beyond.
Thank you. Okay. All right. This one has no absolute min. All right. Now, in yesterday's lesson, we talked about intervals of increase and decrease, and one way that might be helpful to determine those is to put an X number line down here. And on the next X number line, you can list all the X values at your max and mins. So what is the X value at this max? Negative 1.59. What is the X value at this min? Negative 0.46. What is the X value at this max? Positive 0.41. And then when we look within these intervals, if we went from left to right, going from left to right, what do I do first? What am I doing? I am going up. This is an increasing interval. What does the next interval do? It goes down. So this is a decreasing interval. The next interval goes back up. It is an increasing interval. And the final interval goes down. It is a decreasing interval. So my increasing interval starts off at negative infinity, and it goes to negative 1.59. And then I have another increasing interval from negative 0.46 to 0.41. My decreasing intervals are here and here, so that one goes from negative 1.59 to negative 0.46, and then my second decreasing goes from 0.41 to infinity. Okay? Any questions about increasing, decreasing? So if you find it helpful to create a separate little X number line below your graph, then do it. If you do not need that, then don't do it. All right, so in behavior. In behavior always starts off like this. As X approaches negative infinity, what does Y do? As X approaches positive infinity, what does Y do? Now you will notice that some textbooks, if you research, flip-flop these. It really doesn't matter. I like to go left to right every time. Okay? So what is this end doing? It's going to negative infinity. What is this end doing? It's going to negative infinity. Now, I could have known that just by looking at the degree and the leading coefficient. I didn't even have to look at the graph, but I was given the graph, so I'm good. All right, any questions? Yes, sir.
Can you show us how you do it, just looking at the degree and the degree?
Sure. Because the degree is even and it has a negative leading coefficient, we know that it will fall to the left and fall to the right. So both of those approach negative infinity. Negative infinity, negative infinity. Okay, I'm just going to put the solutions up for the bottom three. And then we will talk about them and see if you have questions. And I'm going to come by, and any of you that did not get the right things on your calculator, let me individually help you now. I'm going to pause the video. All right. So far we've studied all these characteristics. Today we're going to add where a function is positive or where a function is negative. That's all we're adding today. Where is the function positive? Where is the function negative? And today's notes, there they are. Okay, so we're going to continue doing all the same stuff, just adding a little bit to it. You'll notice, did I give you the equation for f of x? No. So this is not one that we're going to type into our calculator. We're just going to start by understanding some basics. Can you find the x-intercepts of the graph?
Yes.
Yes. Okay, what's another name for x-intercepts? Or what can x-intercepts also represent? Zeros of the function, roots of the equation. Very good. Okay, so my x-intercepts occur right here at -1, 0 and at 2, 0. So you guys actually could write a possible equation for this graph. If we know the x-intercepts, then we know the zeros of the function, and that would give us the factors. What would be a possible equation for this graph? What factor represents the -1? X plus 1. What factor represents the positive 2? X minus 2. Let's look at multiplicity at the root. This one passes through. Is there any multiplicity? No. This one bounces. Is there any multiplicity? Yes. So what should this factor be raised to? Yes. Okay, let's check out the end behavior. It's rising over there. It's falling over there. So should the leading coefficient be positive or negative?
Negative.
Negative. Okay. Now, this may not be the exact right equation, but it's a possible equation that would give us a graph that looks very similar to this. Okay, y-intercepts, I can see it right here. Did you guys notice last night when you were finding the max and mins? When you were finding the max and mins last night, did you notice that every time you started off, it started on the y-axis? It gives you the y-intercept. It does. Now, if it didn't, it's really easy to find the y-intercept from the equation. You can just plug in 0 for x. Or, if it's graphed like this, you can tell the y-intercept is 0, -4. Okay, because this is an odd degree function, one end goes up, the other end goes down, we won't ever have the absolutes. The only time we have absolute max or min is if we're dealing with an even function. If both ends are doing the same thing, then an absolute is possible. If both ends are not, it's not. They're all relative or local. Okay, so here we have what would we call this point right here in terms of extrema? This is a relative max, so the relative max occurs where the y value is 0 at x equals 2, or I will accept the 0.20. You can either way. Okay, then this would be considered what? A relative min. So we have a y value of -4 at x equals 0, or the relative min occurs at the point 0, -4. All right, increasing, decreasing. On increasing, decreasing, what we're doing is we're looking at the x values as they go from positive infinity to negative infinity. and comparing that with what's going on with this function. So, as we go from left to right, yes ma'am, yes. Do you see we go down first, decreasing. Then we go up, increasing. Then we go down, decreasing. See, this one has two decreasing intervals from negative infinity to 0, and then again from 2 to infinity. It has an increasing interval from 0 to 2.
Do you have to put both of them?
Yes. Okay, so the last thing is end behavior. And on this one, the end behavior, as x approaches negative infinity, what does the y value do?
Positive.
It approaches positive infinity. And as x approaches positive infinity, what does the y value do?
Negative.
It approaches negative infinity. All right, so that's everything we've done so far. So today we're adding positive and negative intervals. Over what interval is the function positive? Well, the y values are always positive above the x-axis. Aren't the y values positive on what I just highlighted in green? So, when we look for this, it's going to be where the function is above the x-axis. That's where it's positive. So this one is positive. It is positive from negative infinity to right here. What's this x value right there? Negative 1. Now I can't include negative 1 because at a value of negative 1, the function actually equals 0. That's the 0. So it's 0 at negative 1. It's not positive. So we can't include the negative 1. Okay? The next question says, over what intervals is the function negative? In other words, over what intervals are the y values of the function negative? Below the x-axis. So now we're looking at negative. Where is it negative? It is negative below the x-axis. So this is negative here to here. It's negative. And then it's also negative on the other side of this point. But at 2, it's not negative. It actually equals 0. So it is negative from negative 1 to 2, not at 2, so I can't include 2, and then from 2 to positive infinity. It is negative. So positive above the x-axis, negative below the x-axis. Okay, now let's look at the last two questions. All right, this says, based on the graph above, approximately where is the function equal to negative 4? And where is it greater than or equal? So I'm going to take this graph and copy it over on a new page so we can look at just these two specifically. Where is it equal to negative 4? So where? Right there. The function or the y is negative 4, and where does that happen? It happens when x is, what is the x value there? 0. Okay, the next one, based on the graph above, where is the function greater than negative 2? Okay, so let's throw in a line right here at negative 2, almost. So where is it greater than negative 2? Above this line. It is greater than negative 2 above that line. So it's greater over here, and it's greater from here to here.
So what do we write for that?
Okay, so we got two intervals we have to write. For from negative infinity to right here, it is greater. So we have to figure out what this x value is right here. We'd have to figure out that x value and figure out that x value. So if this were a calculator problem, we could actually find this intersection. I'll show you how to do that in a second. We're going to have to estimate. What do you guys think this x value is? About negative 1 point what? No, that's not 1. Negative point.
0.7.
0.7? 0.75? Okay. So we're estimating a little bit. This one's real easy to see. This one's 1, negative 2. What would you call this one? About 2? 2.75? Okay. Okay, in just a moment, I'll show you actually how to find these points specifically on your calculator. So, where is it above that? So we would say from negative infinity to negative 0.75. And then again, from negative 2, negative, that's not negative 2, this is a positive 1 to 2.75. Okay, so pull out your calculator and actually put this equation that we made up in there, and let's see how close we are. I'm going to Desmos just because it's quicker. Let's see. X plus 1, x minus 2 squared. I think we nailed it. All right, and now I'm going to hit a second equation, and this is what you can do also. Negative 2. So this one we could tell was perfect. We got really close. This is 2.732, and this is negative 7.32. So Desmos is really nice, and it's really easy to see where those intersect. So we got really close. Okay, if you had to use your calculator, it's going to take me a minute, so when I finish recording, I'll show you the calculator. But we can do the same stuff. Okay, so you go ahead and work on the you try on the back. I'm going to end the recording for today. And the rest of it will be on the notes.